Hi everyone, David Mala here. Today I'm going to show you something really cool. I've had a lot of people ask me, well, what if I don't want to do a full-length custom Arima model and I just want to do an auto Arima quickly? I want a quick method for some forecasting, for some data, for some time series data. So that's what we're going to do today. We're going to show you how to use the auto Arima package in R. And you're going to end up with a nice graph like this, which is going to forecast your data and show you exactly how to do it. So this is 2016 and 2017 data from an auto body shop. Here's the data right here. You have by week, week number, year, month, transactions, items, sales, and the average transaction. So an auto body shop, maybe the average, it's pretty expensive, but they do a fixing the paint, fixing the body work, fixing the frame might be more expensive. It depends. Then you have some months where it's lower. Maybe they have fewer accidents then, or maybe they had more of like door dings and smaller repairs then. So that's what this is that we're going to be showing today. So we've got 2 years of data, right? 2016 and 2017. Let me open this up so you can actually see the full screen here. And so we're going to start with we got 2 packages we're going to use today. Not a whole lot. It's very simple stuff. So your packages are Read Excel right here, and forecast, which is right here. So if you don't have these, just use like this, install.packages, and then the package name. And the the data set is obtained through this line right here. So all we do is read underscore XLSX, which is a part of the Read Excel package, and then the location on your computer, desktop, laptop, whatever it is, of where your file is. That's the name of my file. It puts it into this data frame called data. Next we're going to use the TS, which is the time series function. It's called TS, to place this in time series format. Even though you saw the data, it has it by month and date and all that stuff, we need to have it in a time series format. So what we do is we use this, and here you're going to see we have TS, the name of the data field or the data frame, which is data, and then we have whichever field or column we're going to pick that we're going to forecast off. So in this case I'm using sales. I could have used transactions or any of the other fields that I want to, but in this case I'm going to use sales because it's probably the most likely one that we would do. Then what we have to do is we have to look at this. Okay, so we need the frequency. So the frequency is going to be, if it's quarterly it's 4, if it's monthly it's 12, if it's weekly it's going to be 52, if it's going to be daily, it'll be 365, and so on. Now there's sometimes when this gets a little different. So for instance, if you have a time frame in your data that's not quite weekly, so you have something that is like a week plus 4 or something like that, that's going to change this to be something like 30 or 40. Also, some people like to use custom modeling and boosting and and tweaking to make to overfit, which you can do, and in that case you would see this number change. But for this is a very straightforward, easy method we're going to do here. So we're just using 52 for the weeks because it's weekly. Then what we have here is you have to put in your start, year, and month. If you don't, it won't show the years or months down here. It would only show 1, 2, 3, 4, 5, something like that, which is not meaningful. So that's what this does right here. And so you run this. Then we're going to plot the time series function or formatted data. So if you plot the TS data, this is your original data, so you end up with this, right? See that? Now if I didn't use this C 2016, 1 right here, this right here, then down here I would just have numbers, which would be less meaningful. In this case I have 2016 and 2017. Now obviously I have .5s in the middle for each. And here's your time series data. So it shows you the breakout of the data for this over time. So that's what this plot function does right here. Next what we're going to do is we're going to use the auto Arima function, and we're going to get the optimal auto Arima model. So this is where it's going to be a 0, 0, 0, most likely, but it may not be. So what we do is we run this right here. So let me just show you what auto Arima, that's this right here, of the TS data, time series data, does. So we just do that. And it gives you this little blurb down here. Let's pull this up so you can see a little bit better. And it starts right here. And in this case, it's 111. It's saying for this data, and that's fine. It's saying that 111, which is the normal default for most BI applications, and it'll give you some other added numbers here. But what I want to show you is once we have this, what I want to do is I want to actually forecast based on this, right? And we're going to actually test the accuracy of this and see how good this Arima really is later on. And keep in mind, every data set's different. So just because one person gets a 98% accuracy, another person gets 50%, if it's not the same data set, if it's a different data set, the data could be more variant, could have more missing numbers, could have trending, could have hiding campaigns hidden underneath it that can, throw the numbers off. And obviously when you look at our numbers here, when you look at this, you see the first year is a lot more standardized. The second year has a lot of variance thrown in it. That's going to throw our accuracy off a little bit in the second year, but that's the way the numbers were. So with this, what we're going to do is we're going to take this, and we're going to put this in the Arima 1 frame, right, just like this. And then next we're going to do is we're going to run the forecast right here, and we're going to put that in forecast 1. So we have that here, and so the H equals 17 is how many periods do I want to forecast out. So we're doing weekly, so 17 would give me basically 4 months or so of data, and that's what I want to do. I could do it for less, I could do it for 15, I could do it for 12, I could do it for 10. 10 would be a little bit over 2 months if you look at 4.23 weeks per month. Okay, so that's where the H equals 17 is. That's not the same thing as the frequency up here. Okay, H is the number of periods, in this case weekly periods, that I'm forecasting out of. Okay, so now to show you this, if I take forecast 1, which is where I put this in, let's just do this, right? Hit enter. And oh, you know what? I misspelled it. This is where you got to be very careful on how you spell stuff in R. So let's do it again. There we go. There we are. Okay, I forgot to put an E in there somehow when I was doing that, but that's fine. Okay, so yeah, see, that's where it says error object forecast 1 not found because we didn't have the E in there. But regardless, here's the main thing here is you have both an 80% and a 95% confidence levels here, upper and lower bounds. That's what these 4 right here are. And then this first one right here is your actual forecasted value. And what you'll notice is, as you go through this, it starts to get over here, it gets very close, and then it stays the same as it gets out here. And there's a reason for that. Okay, this is an Arima model, and it's going to do that towards the end depending on the amount of length of the H period or the forecast period that you pick. Now let's go to this. So we did that. Now let's plot our forecast, right? Let's plot the actual, so the forecast 1 is the actual forecast, and let's plot that. There we go. That's what you saw earlier when we first started this, and it looks very plausible. If you go straight across here, that's about right. That's pretty much right. And then it shows you the 80% and 95% confidence intervals. So obviously this is the 80 and this is the 95%. And so the wider you go, the higher the percent that it'll be fit in that range. Now let's go to the next one. So we already plotted it out. Now let's plot the residuals, because the residuals will tell you if we have congruence or if we have variance and how much of each. So let's plot that out. And if you look here, you start at the 0 here. The first year is pretty good. And then as I told you, the second year has a lot of variance. Maybe there was a huge campaign or spike here. Maybe there was a lot of advertising done at different times and sales, or maybe there just was bad weather that caused a lot of accidents that caused this huge spike here, and then after that spike had a huge drop because people that would have come here came here. I don't know. So next what we want to do is we want to look at, so this looks, you're going to see because of the second year here, their accuracy is going to be a little bit off, but it's still going to be very good for this. In this case, when you have variance like this in the second year, you may want to go with a custom Arima model, and we have that in our videos here already for you. This is just a quick method to get you to forecasting. Okay, if you want that, go back through my videos and you'll find it. Look under Arima models, look under dealing with seasonality, things like that. So next, we're going to take it and we're going to actually plot the norm range of these residuals. So here you have the sample quintiles against theoretical quintiles, and basically what you want to see is a line that goes straight like this, but we have one over here that's a little bit out, and then we have these starting to get a little bit spaced out. So what's happening here is, as I told you, in the second year we have some higher variance that's going to affect our values at the end that you'll see, but it's still going to be okay. So next we want to do is we're going to look at the ACF and the PACF, autocorrelation and passive correlation. And so when we look at this, it's pretty good except for at the start right here. This one right here is a little bit off. But the rest of it pretty much all falls in line. And that's what you want to see. And with this one we have one lagging area over here. That this could be dealt with to get higher accuracy, again with a custom model that would put this in. So instead of one AutoArima model or Arima 111, which is what we have here, it might have a number here that you're going to put in the 001 or something, whatever it is, depending on the lag for that. So we've got the ACF and PACF. They're pretty good. So now let's look at the summary and the accuracy. So we have two ways to measure our accuracy with our forecast. So let's take a look again at our forecast here, where it is right here. So let's plot this up. And we're looking at that, and that looks pretty good in line with it, right? So if we were to follow this, it'd probably go within this range, would be good. So, but we want to know more about it. So we can use the summary right here. Let's bring this up a little bit. So summary gives you this little bit right here. And what it does, it gives you the model, the Arima model, and the numbers behind it, the PDQ values they're called. And we're not going to delve too much into those, but what we want to see here is this guy right here. So this is the MAPE. And that is the percentage error for this. So basically the way that this works is one of the leading values or ways to judge accuracy. So what you do is subtract that from 100. So our accuracy here would be about 60%. Okay, which is not the most accurate, but as I told you, we have a lot of variance in this second year. So if we were to run this just for the first year, our accuracy would be a lot higher. But still, it's 60% accurate, which is better than flipping a coin, which would be 50%. And that's one way to look at it. And then you've got all these other leading indicators in here too. But let's go and look at this. And this is the same way. So we got accuracy. The accuracy function does the same thing. Gives you the exact same without the little bit in front of it. So you can use either one. And what it does, it gives you the MAPE the same way. 40.4937. So the accuracy here is about 60%, 59%, 60% with this data set. Again, it's a very variable data set, or a higher variance in the second portion. And then you can again plot it like we did here. And if you want to see the forecasted values, just make sure you spell it correctly. And here they are. So you have your forecast for 17 periods. And you can see it right here. This is the column right here, where it starts at 38,858, and it goes on down and then stays at about 34,438 through the rest of it. So that's how you do AutoArima. That's how we forecast in R very quickly and easily. It's just a few lines of code. Let me open this up so you can see it a little bit better here. And that'll give the whole name of the file that I'm using. And I'm going to post this file on Kaggle, and I'll give you a link down below of how to get to it, and or just you can just use it, just download it and use it. And this covers everything you need right here. From, let's bring this down so you can see the whole code from front to end. There we go. So here it is. You've got install packages if you need to install them, the two libraries, Read Excel, Forecast, the data set that we use, the all the different functions that we use from TS data or TS plotting, the AutoArima on down. So this is exactly how you do it, and you end up with this. And you can take this data, the forecast, you could make it, for different weeks, different periods, but it's a quick and easy way to forecast stuff with an AutoArima model. And this will give you your values. In this case it was 111 based on this data. And so that's quickly how to do it. So thanks again for watching. I hope you found this helpful. I hope this answered the question for the people that want a quick, an easy method for forecasting time series data. Please take a moment to subscribe, like, and share, and have a great day. Thank you.